In this video, we are going to look at the integral part of calculus. Now we just look at some basics. So under integration, integration is the inverse process of differentiation, and it is therefore also known as the ant differentiation. So integration, it means finding the function that was differentiated to get the present function. Then also sometimes this process is also known as determining the indefinite integral. Then the second part of integration, this is just the mathematical process by which the exact area under a curve bounded by the x-axis and for a certain interval is found. Now, the part where we use the given interval and the x-axis in order to find the area, this now part is known as determining the definite integral. So definite integral deals with the area, exact area under a curve. Now indefinite integral, we are just trying to find the function that was differentiated to get the present function. Now here what we are saying is let's say we have the first part. Let's recall the differentiation part of calculus, where we said if we have a function raised where x is raised to the power n, so this is the power rule. We said we need to bring the n to the front. We have nx, then we subtract 1 from the exponent. Let's say we have an example of x raised to the power 4. This can be differentiated as we bring 4 to the front, then we subtract 1 from 4. This will give us 4x to the power 3. Now the integration, this is now the opposite, the inverse. So the integral in terms of power rule, if we have x raised to the power n of dx, this can be integrated by you add. So you add 1 to the exponent over n plus c1, then plus c. Let's say we want to integrate 4x raised to the power 3. So we can say this 4x raised to the power 3 can be integrated as 4x, we need to add 1 to the 3, so 3 plus 1 over 3 plus 1, then plus some generic constant. So we can see that we have 4x raised to the 3 plus 1 is 4 over 3 plus 1 is 4 plus c. 4 into 4, we have 4 raised to the power 4 plus c. So we are able to see that we are able to get the function that was differentiated before. So this is the part of calculus that we are dealing with. Now let's look at some rules. The first rule, we'll look at if we have a constant. Let's say we have k as our constant. So for you to integrate a constant number, you need to multiply that constant times x. So our k is constant here, so k times x, we get kx plus c. If let's say we have the integral of 5 dx, this can be integrated as 5x plus c. Then rule number 2, we look at the power rule. So here we are saying we have x raised to the power n. This can be integrated as n plus 1 over n plus 1 plus c, some constant. Let's say we have x raised to the power 6. This can be x raised to the power 6 plus 1 over 6 plus 1 plus c. So x plus c, x raised to the power 7 over 7 plus c. Now let's look at examples. So examples, we are going to differentiate the following. So the first, we are going to differentiate. Let's have the first example. 7x raised to the power 6 dx. This can be, so we have 7x raised to the power 6 plus c 1 over 6 plus c1 plus some constant. So we can see that 7x raised to the power 6 plus 1 is 7 over 6 plus 1 is 7 plus c. So we can cancel here. We have x raised to the power 7 plus c. So if you want to check if your answer is correct, you can try to differentiate the given part. If you differentiate this part, so if we were to differentiate x raised to the power 7 plus c, it has to take us back to the 7x raised to the power 6. Let's say we have the second example. So we have 3x squared minus 5x plus c4 of dx. So you can pause the video and give it a shot. So let's begin. So the first part, we are going to integrate 3x raised to the power 2. So this becomes 3x raised to the power 2 plus 1 over 2 plus 1. So to the power, you add 1 divided by the same, minus 5x. So x is raised to the power 1, so 1 plus 1 over 1 plus c1, plus the 4 is constant. We said we need to multiply it by x, so 4 becomes 4x plus c, some generic constant c. So we can now simplify 3x raised to the power 3 over 3 minus 5 over 1 plus 1 is 2, x raised to the power 2 plus 4x plus c. So we can divide this. We have x raised to the power 3 minus 5 over 2 x raised to the power 2 plus 4x plus c. So this is our answer for this problem. Let's have some more examples. Okay, so this time let's say we are trying to find the integral of 3x raised to the power 2 plus 6x minus 7 of dx. So this can be integrated as, let's de-integrate the first part, 3x raised to the power 2 plus 1 over 2 plus 1, 6x raised to the power 1 plus 1. So if the power is not shown, therefore it means it is raised to the power 1 over 1 plus c1. Then our 7 is constant, so 7 times x becomes 7x plus c. So we can now simplify 3x raised to the power 3 over 2 plus 1 is 3, 6 over 1 plus 1 is 2, x raised to the power 2 minus 7x plus c. So we can simplify here. We have 6x raised to the power 3 plus 2 into 6 is 3x squared minus 7x plus c. Okay, now let's try a different one. This time we are going to find the integral given the point where the function is passing through. So let's say we have dy over dx is equal to negative 3x squared plus 2x. Now this time the question is, we have been given the point where the function is passing through, which is negative 2, 3. So the first number represents the x-axis, the second number we have the y-axis. Now the question is, find the equation of the function. So if you have been given a point where the function is passing through, there will be a need of finding the value of c. So now let's integrate this part. So where there is dy over dx, we put y. So the integration of negative 3x squared, this becomes negative 3x raised to the power 2 plus 1 over 2 plus 1. Then this 2x raised to the power 1, we add 1 over 1 plus c, 1 plus c. So let's see if we can simplify. So here we have negative 3x to the power 3 over 3 plus 2x to the power 2 over 2 plus c. So we can cancel here. We have negative x raised to the power 3. Here also we get positive x squared plus c. So after we are done with integration, we can substitute y. So we can see from the point, we can see that the value of y is 3. So where there is y, we put 3 is equal to negative. Now here our x is negative 2, so we get negative 2 raised to the power 3 plus negative 2 raised to the power 2 plus c. So we have 3 is equal to negative. So first let's expand the inside. So negative 2 is raised to the power 3, so we have 3 negative 2's. So plus, here we are going to have negative 2 times negative 2, then plus c. So here, so negative 2 times negative 2 is positive 4 times negative 2. Inside we have negative 8 plus negative 2 times negative 2, we get positive 4 plus c. Then we can see that we can expand the negative times negative, we get 8 plus 4 plus c. So then we can continue here. So 3 is equal to 8 plus 4 is 12 plus c. Then we're going to move our 12 to the left side here so that we solve for c. So we get 3 minus 12 is equal to c. So 3 minus 12 is negative 9. So now the equation, the original equation, now we have y is equal to negative x raised to the power 3 plus c x raised to the power 2. Now where there is c here, we substitute with negative 9. So this is now the function of the original function. Okay, now let's look at where we can use integration, where we can use the u-substitution. So say determine the following. So the first we are going to integrate is x, where we have 3x squared minus 5 raised to the power 6 dx. Now here we have a composite function, so there is one function inside. So the first step here to do is we are going to let u is equal to the inside function. So the inside function is 3x squared minus 5. So what we are going to do is we are going to now differentiate this function with respect to x. So let's begin. Du over dx is equal to, so now here we are dealing with the differential. So you are going to differentiate this function. So we bring 2, we multiply 2 times 3, we get 6 raised to the power 2 minus 1 is 1. Then the derivative of a constant number is 0. So now let's solve for dx. So over 1 we cross multiply. So du times 1 is du is equal to 6x times dx is 6x dx over 6x over 6x. So we can see that dx is equal to du over 6x. So now we have made dx the subject of formula. So we can go back from here. So we are going to do, we have, so here we have x. Now where the inside function must be substituted by u. So we can see we have u raised to the power 6, this power 6, then multiply by the dx. We are going to substitute the dx with everything that we have formed here. So this multiplied by du over 6x. So now we can see that we can cancel this x and also we can cancel this x. So this is same as 1 over 6. So we are going to move the constant to the front. So we have 1 over 6, the integral of u to the power 6 du. Now, after reaching this stage, we are going to integrate the u raised to the power 6 by using the power rule. So we can proceed. We have 1 over 6 times u to the power, so we add 6 plus 1 over 6 plus 1 multiplied by constant. Then we continue. We have 1 over 6 times u to the power 7 over 7. Not times plus a c. So you can multiply 1 times u is u to the power 7 over 6 times 7 is 42 plus c. Now, after we are done with integrating, we are going to now, where there is u, we are going to substitute with the function for u. So what they are saying is, we say now 3x squared minus 5 raised to the power 7 divided by 42 plus c. So this is how we integrate with the format of u substitution. Okay, let's have another example. Let's say we have a function 5x squared over 2x raised to the power 3 minus 5 raised to the power 2 dx. Now, so which one do you think we should let u equal to? So always you let u equal to with the function with the highest exponent. So we can see that the numerator function, the x the power is 2, the denominator the power is 3. So the denominator is the function with the greatest power. So this is what we are going to let u equal to. So we'll say let u equal to 2x raised to the power 3 minus 5. So we are going to differentiate this one. So this becomes du over dx. Then we are going to use the power rule. So 3 times 2, 6x raised to the power. So immediately after multiplying the power times the constant, you subtract 1 from the power according to the power rule of differentiation. So 3 minus 1, that's 2. Then the integral, the derivative of a constant number is 0. Then we can now isolate dx, so we cross multiply. So du times 1, we have du is equal to 6x squared dx. Then we can divide by, so we can cancel, we get our dx, then is equal to du over 6x squared. So the importance of the first part, we are trying to make the dx the one that we are going to substitute here. So then after we are done with making the dx the subject of the formula, we can now replace the denominator function with u. So this will be 5x raised to the power squared over u raised to the power 2. So you need to look at the power that you have here. So raised to the power 2 times then the dx we substitute with this one. This becomes du over 6x squared. So we can see that we can cancel this x squared. Then we'll move 5 and 6 to the front. So this becomes 5 over 6, since 5 is on the numerator part and 6 is on the denominator part. Then the integral of 1 over u squared du. Now we can't integrate if whatever part that you are integrating is on the denominator. So what you are going to do is we need to move this to the top. So this will be 5 over 6. Then when u squared moves to the top, the power becomes negative 2. Then we are going to use the power rule for integration. This is 5 over 6 times u raised to the power negative 2 plus 1 over negative 2 plus 1 plus c. So this, we can see that here we are going to have 5 over 6 times u to the power negative 2 plus 1 is negative 1 over negative 1 plus c. So we can multiply negative 1 by 5 over 6. This will give us negative 5 over 6 times u to the power negative 1 plus c. Then what we are going to do is we need to move the u variable to the denominator so that we change from its negative to positive. So this what means is negative 5 over 6 times 1 over u plus c. So now after we are done with integrating, where there is u, we substitute with the function, this part here. So we say u is equal to 2x raised to the power 3 minus 5, then plus c. So this can be 5 times 1 is 5 over 6x, 6 open bracket 2x raised to the power 3 minus 5 plus c. So this is the method that we call the u-substitution. And that's it for this video. Thanks for watching.